guys, and today we're going to continue with our lesson of normal distribution. So, we're going to be going ahead and looking at z scores, what that really means, and the formulas for finding and converting your x scores from your z scores. And if we have time, we might even look at a few practice problems. So, let's get started. So z-scores are really our basic distribution. And in last video we looked at normal distribution, and now it was a perfect bell-shaped symmetrical curve. Well, a z-score is kind of like that. And we also have a few of our rules, you could say, for z-scores. That your standard deviation has to equal 1. If it equals 1, then you know it follows that specific pattern. And then our mean, and I'm going to say our mean is going to have to equal 0. Okay, so that's basically all you have to remember. For z-scores, our standard deviation is 1, and that our mean is 0. And then we also have a specific formula, which we're going to explore just now. So our z, as in our z-score, equals x minus the mu, and we'll discuss what all of these symbols and variables mean, divided by our sigma. Okay? And now we're going to basically kind of break up this whole formula. And it sounds really complex, but it's actually not. So what it's really saying is that to convert from an x score, and you know what, we can even write that here, from our x to our z score, because that's important. From just a normal situation into your basic distribution z score, where these basically these like aspects and rules are assumed, we're gonna have to have the observation. So our x is going to be our observation of our scenario, minus mu, which also means the mean, divided by sigma, which we discussed in our earlier videos, which was population standard deviation. So make sure you know that it's not standard deviation for a sample size, it's for a whole population. So I can just go ahead and write that. So population standard deviation. All right. And then our mu, I can go ahead and write really quick. That's our mean. And if you guys want, you can go back to my other videos where we explain all these symbols. And then x is just going to be just like an arbitrary value right now. Later, it's going to mean your specific observation in your problem. So that's really it for z-scores. And now we're going to be going ahead and looking at a few problems to calculate z-scores. So for example, if it was what is your z-score for, let's say, if you have a score of basically 82, like as in percent um of like a assessment, then what is that into a z-score, assuming that the standard deviation is 1 and the mean is 0? Well, that's really easy. But then in the problem, they also give us that the mean is 72 and a standard deviation is 8. So our mean is our mean is 72, not 82. 72, and our standard deviation is going to be 8. And these are basically all the variables that we need try calculating the z-score and using the formula. And be sure that you don't get mixed up with which formulas to use for what. Okay, so all you have to do is going to be x, which we can see right here. This is going to be 82 minus the mean, and the mean we see here is 72, divided by our sigma, which our standard deviation for our population, which is given that is 8. So that's going to be 10 divided by 8, which is going to be 1.25. All right, and then we can go ahead and write here 1.25. So that is going to be our z-score for a normal score of 82. And what does that mean? Well, we can go ahead and draw it on our graph. If this is going to be 0, and that's going to be, let's say, 1, and over here, this is 2, well, 1.25, we can draw it in another color. It's going to be about here. And that's going to be this area in which a normal score of 82 would fall in. Okay, so that's really how far it goes for z-scores. And any other calculations that you would have to do with z-scores, that's basically gonna be in your calculator. So basically, if they're saying a probability of a z-score being between, let's say, 0, 1, 0, 2, then that's something that you would have to add on your calculator. But really, it's pretty easy to do it by hand, because between 1 and over here -1, well, that's going to follow our empirical rule, where we stated that it follows certain distributions of the 68, 95, and 99.7% rule. So if you really wanted to find, we know that between one standard deviation of the mean, so that's between -1 and 1, that's going to be 68%. Well, between 0 and 1, that's just 68 divided by 2, which is going to be 34. And there is a certain way to write it. So let's go ahead and explore that. So it's going to be your probability. If they're asking for a probability, then this is what you would have to enter. Probability of 0 is less than z, and then it's less than 1. So that really takes us into saying that it's between 0 and 1, which is gonna be, as we said earlier, 34 or 34%, because it was 68 divided by 2. And then if there's other complex ones, then you would have to enter those in your calculator. But this is the way of how to write it. And you might be thinking, well, what if they had like an equals to sign there? Well, it really doesn't matter, because that difference is so small that it won't alter the situation in any way. Okay? And if you're just wondering that, well, what if I had to do it in my calculator? Then all you have to do is go ahead, just go to your calculator, and all you have to do is press second and vars, which is basically that distribution button. And then in that distribution button, it says, do you want normal distribution PDF or CDF? So click 2, which is normal CDF. And then there has a lower and upper bound, and then there's mu and sigma, which are basically these characteristics that we explained here, and also the ones in the formula. So our lower bound is going to be our minimum value, which over here, let's enter this in, was 0. So go ahead and press 0 for lower. Our upper bound is going to be 1. Our mean is going to be 0, standard deviation 1. Go ahead and press enter, and then you will, in fact, get 0.3413, which is going to be 34%. So guys, I hope you liked this video and learned something new. See you later.